It has started the recording. So I will just, okay. Now, isn't that I said go through the questions, and if you have a problem, send me which question you have a problem with so that I can be able to help you. I have rejected, I think, 4 to 5 people not answering their emails. Reason being, they send me questions and they don't send me their workouts. Don't tell me I have a problem with this question. Show me what you have done so that I can see your mistake and then help you with that question. Is that clear?
Yes, ma'am.
Yes, ma'am.
Thank you. And the other thing is, we'll only do questions at the end of the class so that we don't eat up time for this week's work. Okay, let us start. So today we're looking at, I think we're looking at inverse of trig, right?
Yes, ma'am.
Thank you. So we're looking at the inverse trigonometric function. So they say at the end of this learning unit, you should be able to differentiate the inverse of trigonometric function, right? Do you remember what is an inverse of a function?
Yes, ma'am.
What is it?
Oh, let's say you are given an equation y is equals to y is equals to, or x is equals to sine y. To get y, you have to change the sign into the inverse, meaning it will be sine negative to the power -1.
Okay.
Then that's the inverse of sine. That's the
Okay.
inverse.
I think another way
Okay.
of explaining it in terms of like English is inverse is kind of like the opposite way of approaching it. Like if I had to come to with an English way of explaining it.
So basically the inverse is the opposite way of which, what's this? If, okay. For example, if you are taking values, let's say A is the domain and B is the range. If you're taking or X or Y, if you are taking values from this, substituting into a function and then getting answers which are in Y, the inverse is actually doing the opposite, taking the Y value and getting the X value, right? So now for this particular part, I want you to go and read this part. This is very important. Just go and read and understand it. If you do not understand it, come back to me, right? Now, remember when you were looking at trigonometric functions, trigonometric ratios between grade 10, 11, and 12, what you did is you had sine of theta is equals to, maybe let's say √2/2, right? And they tell you to go and find theta. Do you remember that?
Yeah, the special triangles. Yes, ma'am, we do.
Yes. So then that you were actually using the inverse to find the angle theta. So by doing theta is equals to sine arcsine of √2/2, second function, then and finding the value of theta, in this case theta is equals to 45 degrees. This is when you were using the relationship of inverses to find the angle for theta. Is it clear? Yes or no?
Yeah, it makes sense, man.
Okay. So now there's a property. Let me just highlight this property because I might have asked it and people got it wrong. There's a property that says that if you take an inverse, right? Can that person mute?
Please mute.
Who's that person?
Tati, mute.
Thank you for muting. You see, now you are distracting me, guys. Now I was interested to hear. Okay, so there's this property. It's a property for inverse function and its functions, right? So it's important that you understand it. Now it says that if you have a function, those who did pre-calculus and those who did calculus, they'll know that property. It says if you have a function f of x, right? And the function inverse of f of x, right? If you substitute the function inside, that is, if you take the function, substitute in, what's this? If you take the inverse, substitute it into the function itself, you get the value of what? What do you get? Hello?
The value of y?
You get
No.
X.
No.
Well done. You get x. Right? Now, same applies that if you take the inverse, inside the inverse, put the function f of x, you'll get what? You'll get x. Does that make sense?
So it's basically similar to what quotient rule, except you'll be using the inverse.
Yes. It's an not quotient rule. What's this?
The one
Chain
where
rule.
chain rule, the function within a function.
Yes, a function inside of a function. So meaning that if you take a function, put inside the inverse, then you get x. And if you take the inverse, put inside the function, you also get x. That is why this relationship of what? Of arc sine. Oh, I'm ruining this. What's this? The notes. That is why when you were told to find sine of theta is equals to √2/2, what you did is actually take the inverse both sides, meaning that you took the inverse arc sine of theta both sides. Like this. So meaning that, as we said, because of that property, because of the inverse property, we said if you take a function, put inside, if you take an inverse and put an inverse of a function and put this the function inside that inverse, in this case, you get what? Theta is equal root on how.
Ma'am, you're
Guys,
cutting.
am I
I
losing
think
people?
no, your internet is bad, ma'am. We couldn't hear you for a second.
And
We're losing you.
marking you delaying.
Okay, give me a second. Give me a second. But does the inverse property make clear, guys? What am I saying? Is the inverse property clear? Yes or no?
Through your presentation, yeah, but I feel like we need to see more, actual examples to see if we can implement it.
Or can I do it? Can I do that in the exam on the assignment?
Wait, repeat the question.
So can I take it out in the exam or in the assignment and you guys will be okay with it, right?
Yeah, but I think you can try to take it out first on the assignment, ma'am.
Okay. I'm not promising. But from here, it makes sense. Yes or no?
Yeah.
Can you please explain a little bit?
Okay.
I was a bit delayed because of the distraction. I'm sorry.
You saying what? I should what?
Can you please repeat it, ma'am, so it's clear?
So I'm saying that okay, did you understand this part over here?
We're not sharing anymore.
Maybe not sharing your screen.
Oh. Thank you. So do you understand this part here, over here? Hello? Can you guys see
I'm saying
this
that
one?
I didn't get that part because I was distracted. That's why I'm asking you to repeat it for me, ma'am. Sorry.
Okay, so I'm saying that if you have a function f of x and you guys say you know how to find the inverse of a function, right? If you take that function and substitute it inside a function inside of a function, then you will get what? You will get x, right? Or if you take the inverse first and then put inside the inverse the function, then you get what? then you'll get x. That is why when you were asked to find sine of theta is equals to √2/2, which is in your grade 10, 11, and 12, when you were asked to find the what's this theta, you actually took the arcsine. Basically, what you did was that you said the inverse of sine, substitute sine inside, and what you did on your left-hand side, you also did on your right-hand side. And because of the inverse property, this sine and this sine, they sort of cancel, and you're left with the arcsine and the sine that sort of cancel, and you're left with theta, which is then equals to the inverse of sine √2/2, which is then equals to 45 degrees. So the property of the inverse of the function, the property of inverse of function is very important that you understand it and you know it. Makes sense now.
Got it. Thank you.
Yes.
Makes
Not
sense.
clear. It's not clear.
Yes, yes, yes.
Now,
it's clear.
This is not part of the, what's this? What I explained is not part of the syllabus. They assume you know it. So the reason why I explained it is because when it was in the assignment, I think in the assignment or in the exam, a lot of people got it wrong. That's why here I'm explaining it so that I do not assume you know it. I hope that is clear.
Yes, ma'am.
Thank you. So now today we're looking at the inverse of trigonometric function. So this is the arcsine is the inverse of sine, arccos is the inverse of cos, arctan is the inverse of tan, and then we have arccosec, arcsec, and arccot. All right. So now they're saying that if you have a function, if you have the inverse of if you have arcsine, then the derivative will be represented by this formula over here. Okay, there's something I needed to highlight as well. Look at this. They say that sine to the power of -1 is used as another notation for arcsine. Are we together? Now, sine to the power of -1, meaning the inverse of sine is not equals to 1/sine, because what's this? The inverse of sine is equals to arcsine. So this 1/sine is actually open bracket sine x to the power of -1. So please make sure that you understand what's this. You are able to differentiate the different notation. Are we all together there? Yes or no?
Wait,
Yes,
so
ma'am.
a
Yes.
sine to the power of 1 is not equal to 1/sine.
Yes. It's
Okay.
just what's this? Just represents the inverse of a function.
Alright. Noted.
And remember that when you were representing inverse of function, you say f to the power of -1. When you were representing inverse of function in your grade 10, 11, and 12, as well as pre-calculus if you did pre-calculus and calculus. So let's look at the example.
So, ma'am, before you move on, quick
Yes.
one.
Yes.
So let's say we have sine squared x. It's possible that you can remove that square root and put it outside and square everything, because usually that's what we were doing, like on the previous differentiation, if I'm not mistaken. If we're given maybe, let's say, sine squared x, we could remove the square root outside, like then it's sine x all squared. I don't know if I'm the one who's mistaken or what.
That's
Yes,
different.
we're able to do that.
That's different. Remember, when you this is what you mean, right? You say that when I had sine squared x, you were writing it as sine of x squared.
Yes, yes, yes.
Yes. Now, sine to the power of -1, it represents. You understand? So this represents arcsine of what? Of x. Right?
Okay.
So meaning that for me to write the power, sine of x to the power of -1 is the one that is 1/sine of x. Are we together?
Yes, ma'am. Yes, ma'am.
Thank you.
So wait, I'm confused, ma'am. We were able to
Mm.
move the squared outside the function. Why can't we do the same for -1?
It's because in this case, -1 represents the inverse of a function. right? And if I want to represent the function to the power of -1, it will be represented like this.
Yeah,
and
I get
not
that.
like this. Yes.
So to summarize, -1, I must stay within the sign. You mustn't take it out.
Yes.
Okay, thanks, ma'am.
Yeah. So let's look at the example. I hope I haven't lost anyone. Guys, why are the
I have a
others
question, ma'am.
quiet? Have you eaten today?
Me, I just had my meal. That's why I'm talking to.
No, we haven't.
The others, have you eaten?
Hey, we are hungry.
We are very hungry.
No wonder. Okay, what's the question before we continue?
Yeah, so my question was, ma'am, so the position of the -1 from now on will be intentionally put at a certain place to test your knowledge on this specific rule, right?
Why are you doing this to me? That was one of the tricks I was going to use for the exam or the assignment.
Ah, okay, I got you.
Yeah. So you need to be very careful. That's why I explained it. Okay, so let's go to the example. So it says example 1, arc sine. So in this case, this can be written as y equals to cosec, the inverse of cosec 1 plus x squared. Do you see that? So it can be represented as this or that. So now if you are given, what's this? If you are given the inverse of a trigonometric function, we then go and check, where's cosec? I mean, where's cosec, guys?
Negative f of x over f of x in bracket f of x squared minus 1.
Hey,
Do you see
see,
that?
I don't like cramming. Isn't there a way to prove this? Or am I just wasting time?
No, we'll waste time to prove it. Don't worry, there's a formula sheet in the exam.
Okay.
Yeah. There's a formula sheet on the exam. So do you see how it looks like, right?
Yeah.
Yes,
Yes,
ma'am.
ma'am.
So let's go and write it. Then you remember it. So it's what? F of prime of x over f of x square root of f of x squared minus 1. Am I right?
It's a minus f of prime. It's a minus.
It's minus f of prime of x.
At the top, it's minus.
Okay, thank you. It's minus. Now, I always say to you guys, some of you, I've noticed what you do is you go through the steps on how they did the question in the study guide. You see? And then you get confused. If you can be able to find a way that makes it easier for you to solve the problem, that's what matters, and get to the answer. Now, with me, normally what I do is I go step by step, right? So we know that the derivative of this function over here of arc cosec it's this over here. So they say that if you have arc cosec of a function, f of x, then its derivative is this over here. Now, what is f of x? Let's do it step by step. What is f of x in this case? F of x is equals to
1 plus x
1
squared.
plus x squared. X squared.
X squared, right? Now, do you look at this? They want the derivative of f of x. They want f of x and the square of f of x. Are we all together? So let's do it step by step. You can do it the way they did it in the study guide and substitute everything, or you can do it step by step. So I know that the f of x is equals to 1 plus x squared. Now the derivative of f of x is equals to what? Is equals to 2x. Am I right? Yes or no?
Yes, you're
Yes,
right.
ma'am, you're right.
Thank you. So then we say dy over dx is equals to minus the derivative of f of x. Now, always put f of x in the brackets, guys, because sometimes you might have plus 1, and then if you just say 2x plus 1, then it becomes wrong. So always put it in brackets, because there's a negative sign over here. So put it in brackets. We say the derivative of f of x is equals to what? Is equals to 2x. So put 2x in bracket over what is f of x? F of x is what? Is 1 plus x squared times the square root of what? Times the square root of f of x, which is 1 plus x squared minus 1. Now, substituting like this only and leaving it like that will not give you all the answers. Is it clear?
You have to simplify it further.
Thank you. So where do we start?
Removing the root. That's what I like to start with. But maybe that's not the first step to start with.
Yeah,
Okay,
it's not the
we
first
can
step
try
to start.
and okay, we can try and factorize in the root for the 1 plus the square root of 1 plus x squared.
Okay, let's do that. So this is minus 2x over 1 plus x squared. Then what do we get?
Remember, you're writing something. On my side, the screen is frozen. Oh, there was a delay. Okay.
What is that?
What you are writing and what you are saying, there's a delay.
Oh, guys, don't say that. Is my
Sorry,
network bad today?
I think so.
Hey, man.
Because we can hear
is
you,
it raining
but
by your side?
Yeah, the weather is not good.
What do we say about you getting rain?
No, oh, I'm sorry, guys. I'm really sorry. I think I'll have to move location for next week. Okay. So what's the answer in this case?
So after factorization, we're going to get x to the power of 4 plus 2x squared.
So you're saying here we get what? No, let's do it step by step.
Step by step. Okay, so we're going to open 2 squared, 2 of them, and then after that we're going to do factorization, which will yield 1 plus minus 1, and then the ones are going to cancel each other, where we will be left with x to the power of 4 plus 2x squared.
Did you hear what she said, guys?
A quick one, ma'am. I don't understand. Are
Yes.
we factorizing or are we
Wait, are we
expanding?
factorizing?
We actually,
Ma'am, are we factorizing?
Yeah, we're
or are we expanding?
factorizing.
Are we factorizing or we expanding it?
Guys, the English is very important. We're not factorizing, we're expanding.
Yeah, I think so. Yeah,
Oh,
now
okay.
it makes sense.
Yes. So when we're expanding, we're taking 2 brackets and we're making it, what's this? We're making it a summation or difference of x squared plus 4x squared, whatever. That is expanding. But if you have x squared plus 2x plus c, and then you make it into brackets, that's factorizing. Make sense?
Yes.
Yes, ma'am. So,
Yes.
so if we are expanding.
Mm-hmm.
Yeah,
Yeah,
so
so-
if we're expanding, yeah.
No, you can go out. You can go ahead. I wanted to expand it, but you can go ahead. It's fine.
Okay, so you want to expand it. Let's expand it. What do I do?
you need to open 2 brackets since there's a squared.
Okay, we open 2 brackets.
Yes.
Do you agree what she says?
Yes, ma'am.
Yes.
ma'am.
Yes.
Yes.
Can I show you a shorter way of doing it?
Yes, please.
We do like shortcuts.
Hey, me, I like shortcuts. So you have 1 plus x squared, ne? Squared, right?
Hmm.
You first square the first term. What is the first term in this case?
It's 1.
Hello? What is the first
1.
term in this case?
1.
You
1.
first square the
1.
first term. After squaring the first term, you say 2 times this times that. That is what? Plus 2x squared. Then you square the last term, which is to the power of x to the power of 4. Do you see what I did?
Yes.
It's still coming.
No, there's a
There's a
delay,
delay.
ma'am.
Yo, it's still writing. Hold on, give it a second. It'll finish now.
Today I'm in trouble. Okay.
I'm a food.
I think there's a delay in every network I use today. What about this one?
Please share the
Hello?
screen.
Still waiting for you to share.
Okay.
So basically, ma'am, you use this technique, which we also use when we are factorizing, what do you call this? Cubic function, like a cubic function. I don't know if...
Yes.
Okay, I got it.
Basically. Yeah, instead of opening brackets inside and whatsoever, so you can square the first term, multiply. As I said, you square the first term, which is 1, multiply by 2 times x squared times 1, which is what? 2x squared, and then square the last term, which is x to the power 4. You can open brackets if you want, right? But then there'll be some form of, or just open brackets then. But I just showed you an easy way.
Yeah. Where were you when I was doing grade 10, man?
When you were doing grade 10, I'm sure I was also doing some grade somewhere. Maybe I was, I don't know, in varsity. So do you see that you can open brackets or you can use the way I showed you, right? So then this becomes minus 2x. It's no longer delaying, right? 1 plus x squared square root of, so that will be 1 plus 2x squared plus x to the power 4 minus 1.
It is a bit.
Are we together?
Delay is even worse.
Guys.
I think maybe, remember now, you can write it down first, and then once you've completed it, maybe just explain it after, so that we can see what you are explaining.
Yeah. Okay, can you see what I'm explaining right now?
Yeah, we can
Yeah.
see.
Yes,
We can
Yes,
see.
we can.
follow.
Okay, if the delay is worse on this one, let me just go back to the previous one then. Promise I'll just have to go on campus. I think today the network is a bit bad because of the weather. Let's just use this one for today. And my apologies. Okay. So we are all together up to this point, right?
Yes,
Yes,
ma'am.
ma'am.
Yes,
So
ma'am.
then this and this, they cancel. So then this is equals to minus 2x over 1 plus x squared root of x to the power 4 plus 2x squared. Are we together there?
Wait, we're waiting for it to finish, then I'll say what to get on now. Okay, it's finished, yeah. Yeah, we're together.
Okay, so now let's go back. Can we simplify it from here?
Yes, we can.
How?
You're gonna take out the x squared as a common factor inside the bracket, inside the square root. So you're gonna have this. You're gonna have the square root of x squared into x squared plus 2.
Okay, that's good. So we can take it out. Let me write it. I hope it appears now. Soon. So we take out x squared, then we had x squared plus 2. Do we all agree with that?
Can you write it down, ma'am? We can see. We can agree after.
No, let's wait for it. You know, when something is loading, it'll finish loading. Okay. I agree with that.
Oh
Yeah,
no,
we
today
totally.
So what else can we do in this case?
Ma'am, the rules for the absolute value state that if you have an x squared underneath a square root, then that is equals to x. So that x is gonna cancel out with the one in the on the numerator.
The rule of the
Absolute values states that if you have an x squared inside a square root, then that's just x. Absolute, which is x.
You're what's this? There's one word that cancels the whole statement. You are correct, but there's one word that made the whole statement incorrect. And what is that?
Is it absolute properties?
The absolute value.
Okay.
Do you understand?
Yes, I
So
do.
in this case, you're looking at the third properties. Does it make sense?
Yes,
But wait, how does that apply if x is multiplying with another function within the root?
It's because the third properties, right? It says if you have a square root of a times b is equals to the square root of a times the square root of b.
Yes,
Yes.
Do you see that? So meaning that this will be equals to minus 2x over 1 plus x squared times the square root of x squared times the square root of what? X squared plus 2.
You see,
And
man,
according to this, and according to the third properties as well, we know that the square root of a is the same as a to the power of 1 over 2. Meaning that if you have a squared square root of a, this will be equals to a to the power of 2, open brackets to the power of half, and then this half times that half is equals to 1. So this is a only. Meaning that that's x squared here will be equal to what? Will only be equals to x. So not the absolute value, but the third properties. Third properties. That's what you learn in grade 10. Are we together, yes or no?
Yes, ma'am. It makes
Yes,
sense.
ma'am.
Exponential.
By the end of this lesson, ma'am, I'll be able to be an auditory learner.
Yeah, I'm sorry. Only for today. But then are the things that I'm writing appearing though?
Yeah, they're gonna appear just now. Okay, they're there. Wait, so does that mean x squared plus 2, it stays in its root form?
For now, it stays in its root form, and we'll see whether do we have to simplify it or not.
Okay.
Yes. So in this case, let me just write it down, and you tell me if it appears. I'm used to talking when I'm writing. Can you see what I wrote?
Yeah, it's still loading. Yeah, it's there now.
Not yet.
It's there.
It's there.
Yes.
It's there now.
Okay. Yeah. So now, as you can see, this x, the square root of x became what? Became x squared. I mean,
yes, x became
sorry,
x.
the square root of x squared became x, so meaning this x and that x, they cancel, so this is equals to minus 2 over 1 plus x squared, the square root of x squared plus 2. And from here, we can't simplify further, so we can leave it like that. Is it clear, yes or no?
Noted. Yes, clear.
Yes.
Thank you.
So, ma'am, are we allowed to like separate it?
Separate how?
Separate like the way you did the square root of x squared and the other
Yes.
third part. Oh, okay.
Yes, but remember, you can't separate the square root of a plus b is never the square root of a plus the square root of b. It's
Oh,
always
okay,
the
I
square
see.
root of
Sorry, I
A
see.
plus B.
Yeah.
So it remains like that. So you cannot separate. Same applies to the square root of A minus B. But we know that the square root of A over B is equals to what? Is equals to the square root of A over the square root of B. I'm saying that because we might need it. Are we all together?
Right.
Yes, ma'am.
Maybe I shouldn't question the rule, but why is that not the case? Like the square root of A plus B is not equals to the square root of A plus the square root of B.
It's because remember in mathematics, if there's a theorem or there is a property, right? And if you can find one example, even if it's correct for all the values of A, real numbers and imaginary numbers or whatsoever, but if you can find one example that disagrees with the property, then the entire property is wrong.
Oh, okay.
Yes. So meaning that in this case, we can find counterexample, right? If you say, for example, 4 plus 9, 4 plus 9 is what? 4 plus 9
is 13.
13, right? Then if you say the square root of 4 plus the square root of 9, do you see that's not 13?
Yeah.
Yes. So that's why the property stays true.
Oh, okay.
Thank you. So you can go and check how they did it in there. You can see they did it differently compared to us. We did it step by step. They just substituted and also did step by step. But we took the longer route. So let's look at example 2. Is the network better or it's still doing something?
We're not
Something,
sure
something. Still doing something, man.
Yeah, but it's trying.
I hope it's trying.
Yeah.
Okay, so with arcsine, do you remember what's the derivative of arcsine?
Yes.
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 It is what?
Derivative of x divided by okay. Divided by the square root of 1. The square root of 1 minus x, the what the x function squared.
Okay, let's go and check. It's very important. So the derivative of f of x divided by the square root of 1 minus f of x squared. Well done. So you can do the way they did it in the study guide, or you can do and say the way I will be doing it right now. You can say, okay, what is the derivative of a function? In this case, we know that what is the function? The function is f of x. So this is f of x is equals to 2x plus 1 over 3. Are we all together? Yes or no?
Yes, ma'am.
Now the other thing is, what rule? How do you find the derivative here?
Quotient rule.
Quotient rule.
I knew you'll say that.
I don't like quotient rule.
Okay, let me say, do not use a quotient rule. What are you going to do?
Wait, before you do the quotient rule, can we not split the fraction into 2?
Well done. Now, instead of using the quotient rule because it's long, you are allowed to split the fraction into 2. So meaning that you are allowed to say 2x over 3 plus 1 over 3. You are allowed, but you are not allowed to split a function like this. So I'm choosing a different color. If you have a plus b over c, it is allowed to say a over c plus b over c. But if you have, for example, let's say a over d and e, this is not equals to a over d plus a over e. So what it means is that you are allowed to split the numerator but not the denominator. Does that make sense?
Yes.
Yes, ma'am.
So in this case, we have what? 2x plus 1 over 3. So you are allowed to say 2x over 3 plus 1 over 3. And this is easy to differentiate, isn't it?
Very easy, ma'am.
Yes.
Yeah, so no quotient rule. I'm not saying the quotient rule is wrong. I'm just saying that sometimes just look at the function first before you use the other rules. Maybe it might be easier. In this case, it's easier to just differentiate and say f of prime of x is equals to, we know this is a constant, it's 0, and we know this is 2 over 3. So this is 2 over 3. Are we all together there?
Yes,
ma'am.
So ttherefore, the dy over dx is the, I hope the network is better, right? So then we know the derivative is 2 over 3 divided by the square root of 1, is it 1? Minus f of x. In this case, f of x is 2x plus 1 over 3 squared. Now, there's a trick that I've learned, all right? Is that most of the time, if you have a quotient like this, guys, ne? And you substitute it under the function, do you see that under the function I didn't substitute 2x, 2x over 3 plus 1 over 3? Do you see that?
Yes, ma'am. We
Yes,
see
ma'am.
that. Yes, ma'am.
The reason why I did that, because then it becomes simple for me to simplify. You can substitute it as 2x over 3 plus 1 over 3. But in this case, if I substitute like this here, it becomes easier for me to simplify. And I'll show you how. Are we all together?
Yes.
Now, in this case, because you can see it's a fraction over another function, you can write this as equals to 2 over 3 divided by the square root of what? The square root of 1 minus 2x plus 1 over 3 squared. Are we all together?
Yes,
ma'am.
You can write it like that.
So for me, I'm writing it like this because I just want it to look simple so that I don't make a lot of errors. So then this is equals to 2 over 3 divided by, let's simplify what is in the square root. So in the square root, it's 1 minus 2x plus 1 squared over 3 squared. Do you agree with me? Yes or no?
Wait, let's wait
Yes,
for it to
ma'am.
finish.
Yes.
Okay. Yeah, I agree.
Okay. So now, what can I do from here?
You can change the division sign into multiplication sign by swapping the 2 and the 3.
No. Let's not change the multiplication sign and the division sign by now. And always remember, when you change the multiplication sign, the division sign into multiplication sign, you actually change what is after that sign, not before that sign. Does it make sense? What I just said?
Yes, ma'am, it does.
Yes, ma'am.
Okay.
Ma'am, does it mean that it won't give you the same answer?
It won't give me the same answer.
What?
You are saying I should change this 2 over 3 to 3 over 2.
Yes, ma'am.
No, maths doesn't work like that.
Square roots first.
Math says that if I have A divided by 1B over C, I only change what is after the sign, this, and not A. So this will be A times C over B. That's how it will look. Do you see that?
Yeah, so basically your
Yes,
3 would be in
yes,
front of your square root if you multiply.
Yes. So basically, in this case, I don't want us to change the square root yet. Let's deal with whatever is inside the square root first, so that it becomes simple.
Okay, then
Yes.
we're gonna just simplify the inside bracket, inside the square root first.
Expand the bracket.
So
Thank you.
Expand.
we're gonna have 1 minus 2x plus 1 squared over 9.
Yes. I don't want us to, guys, the reason why I'm doing this step by step is because I want to avoid more errors. Do you see that okay, the reason why I didn't simplify the 2x plus 1 is because I see that there's going to be a fraction there. So you can simplify it, it's fine, right? But now there's a fraction there. How do I solve that problem?
Can you multiply the 1 by 9 and make the denominator the same? Can you do that?
Well done. So you make the denominator the same. We agree that 1 is the same as 1 over 1, right?
Yes.
9 over 9.
Yeah, 9 over 9.
Right? So this is equals to 2 over 3 divided by the square root of, and we say that if we want to make denominator the same, we take this denominator, multiply with these. So this is 1 over 1 times 9 over 9 minus 2x plus 1 squared over 9. Then we take this one, multiply 1 over 1. We did mention this last week. So this is 2 over 3 divided by the square root of 9 over 9 minus, now let's simplify this. We said that 2x squared plus 1 is the same as, we first square the first term. In this case, the first term is what? It's 4x squared, 4x squared, then we say 2 times 1 times 2x, that is plus 4x, then we square the last term, which is plus 1. Then this is over 9. So then this is equals to 2 over 3 divided by the square root of 9 minus 4x squared minus 4x minus 1 over 9. Are you getting me, guys?
Yes, ma'am, we get you.
Okay, so now let's simplify this. What can we do? Okay, let me make it easy. This is equals to 2 over 3 divided by, we have 9 minus 1, so this is the square root of minus 4x squared, right? Minus.
Ma'am, before we move on, I wanted to ask something. I don't know if it's legal or illegal, ma'am. I was thinking before we can factor out, but okay, there's a minus sign there. Okay, before we can factor out everything, is it possible that we were gonna say 9 minus whatever is inside the bracket squared, then I don't know, we take out the square root outside, and also the 9 below, we change it to 3 squared so that we can cancel the square root. I don't know if it's legal or illegal.
Okay, so the only way that this can be legal in this case, you know, it's what? Because we have a fraction. Yes, and since we have a fraction, we know that the square root of a over b is the same as the square root of a over the square root of b. Do you see that?
Yes.
Yeah.
Yes, ma'am. Yes.
I hope the network is better now, ne?
It's really better, ma'am. Working
Okay,
out.
thank you. So meaning that this is equals to 2 over 3 divided by the square root of negative 4x squared minus 4x plus 8 over the square root of 9. Are we together?
Yes.
So now, meaning that this will be equals to, so this will be equals to 2 over 3 divided by the square root of 8. So let's write it like this. Guys, something is not right here.
Are we doing illegal things?
Oh no, it's fine.
Okay.
Everything's correct. The math checks out.
I'm not sure.
You just square root the 9 below, it becomes 3.
Yes.
And then you're obviously you're gonna change that division sign and you're gonna make it a multiplication, so you'll times by 3.
Yes.
And the 3's will cancel.
Yes.
Sorry, ma'am, I was seeing something there.
So this is equals to, what? This is equals to 8 minus 4x squared minus 4 over 3. Now, remember what I said. If you have A divided by B over C, then this is A times C over B. So then we change the division sign. So this is equals to 2 over 3 times what? 3 over the square root of what? 8 minus 4x squared minus 4. Are we together?
Yes.
Then this 3 and this 3, they cancel. Does it make sense?
Ma'am?
Sorry, ma'am. Is it not 4x there at the top?
Huh?
I'm thinking.
You forgot the X on the 4, ma'am.
Okay, thank you. So does
But,
that make sense now?
Yes, ma'am.
So then there's something else here. Look at this. 2 over the square root of 8 minus 4x squared minus 4x. Are we done from here?
No, ma'am. You can also factor out the denominator with 4. And then apply the root terminology. Now it's root times root.
No, you
And
just
the root
square the
of-
denominator and the numerator. That's all.
Yep.
Square the top and the bottom.
Huh?
Huh?
No.
Can you
That's
not just
not
square
allowed.
the? Can you
You
not square
can't.
the numerator and the denominator?
No, you can't.
No, you
No.
can't. It's not allowed. You can only square both sides. If you square the left, you have to square the right. So if you are squaring the denominator and the numerator, so basically you are confusing us now. You are making us do this.
Common factor.
Do you see that?
I see what you're talking about. Yeah, no worries. I see what you're
Yes.
talking about.
So you can't square that. So what you can do is take out the common factor. In this case, the common factor is 4. Do you agree with me?
Yes.
So
Yes.
then we take out 4. So it will be 4 open bracket 2 minus
X
x
minus
squared
X squared.
minus x. Do you see that? And according to the third notations, we say A times B is the same as what? Square root of
Square root
A
of
times
A
square root
times
of
square root
B.
of B.
Yes. So meaning that this becomes 2 over square root of 4 times square root of 2 minus x squared minus x. And we know the square root of 4 is what? Is 2. So this is 2 over 2 times square root of 2 minus x squared minus x. This 2 and that 2, they cancel. So you have 1 over the square root of 2 minus x squared minus x. Yes. So here we have a longer step because we're just doing things step by step, and you can just go and see how they did it in the study guide. I'm sure they only had few steps. There we go. Do you see that they did it differently? So you can, as long as you can be able to get to the answer and your maths is correct, then that's correct. And it looks like we are correct.
So ma'am, if I leave my answer as dy over the x, it equals to 2 over the square root of 9 minus 2x plus 1 squared. Would I be wrong?
Look at your marks. Look at your marks. There are people who...
This thing you're going to say is 4 on exam, ma'am. I know you.
You see, the thing is, if I say simplify completely, that's another story.
Oh, okay, I understand.
Yes,
But
if I say simplify
if
completely.
If you didn't say that, then if I stop there, will you give me full marks?
Not really. Remember, I said there's a lot of you, and I'm not the only one marking. So you need to be very careful. So always simplify completely. But I will mention in the exam, simplify completely.
We'll say always. We always have to simplify completely. Always.
Exactly.
Yes.
Even if it's not
Yes.
stated.
Yes. It's very important. So let's look at another. Oh, we are done. Oh, no, we're not. Okay. Here's another example. Can we, oh, what am I doing, guys? Can we look at it and then give me a few minutes? Let me see. Where are we? Oh, here. Example 4.
We're doing example 3.
Example 3.
Oh, example 3.
Carrots, ma'am, carrots.
Yay. I'll make sure. Okay. Control Enter. There we go. So let's discuss this one, guys. And I want answers when I come back. I just need to drink water.
Wait, we're supposed to be discussing.
Yeah, we can if you want to.
Okay, so cool. Well, what was the derivative of oxide?
As that one we used previously, it's f prime of x divided by the square root of 1 minus f squared. F squared. F of x squared, yes.
Okay, cool. And what's the derivative of that inner function?
The inner function is minus 2x. Or the inner
I meant
function.
the whole function. Like,
whole
what
thing.
was the derivative of the whole function?
The whole function, we're going to use the chain rule, which will say 1 over 2 times that one will cancel each other. So that means it will have x x open bracket 1 minus x squared, then close bracket times negative 2x. So everything will be the negative 2x squared, open bracket, what is inside the bracket.
1 minus
Going
x
to use
squared.
the product rule before the chain.
No, we use the chain rule. There's no, I don't know. Let's see. We use the product rule. Yes, she's right. She's right.
We
She's
have
right.
to use product
Now,
rule first.
now I
Wait,
was gonna use,
I
now I was gonna
disagree.
use, I was gonna use chain rule. Simpler.
Yeah. The issue about using the product rule is you have the an exponent for the other function.
Because the chain rule is simple. You hold, you differentiate the inside bracket. So
yeah,
in that case, the first one you just do the derivative of x sign. You copy everything that is there, then you differentiate 2x, and then you go.
Hey.
Okay, then there you substitute. So what? Well, what's the derivative of this function? Did you guys write it down?
But I think she's right. You have to use the product rule here. I think she's right.
The product rule, you're gonna use it when you differentiate 2x into 1x minus. I mean the inside bracket. You're gonna use product. Yes. So it's 2 in 1. So it's 2 in 1.
Yes.
All right. So cool. Using product rule, it's what initially it's 2x times the derivative of that. You use chain rule.
I come back.
Welcome home.
Well, welcome, man.
Okay, so in this case, you'll notice that there's a product rule, there's a chain rule, as well as there's a trigonometric function, inverse of a trigonometric function. Did you notice that?
Yes.
Yes.
Okay.
Ma'am.
Thank you very much. It's arcsine. Do you remember the derivative of arcsine? It's f of prime of x over the square root of 1 minus f of x squared. Am I right or am I wrong?
You're
Accurate.
right.
You are right.
Okay. So meaning that in this case, what I'm going to do is, remember I said, I prefer doing it. So I'm showing you a different route. We're not going to follow exactly how they did in the study guide. We're going to follow a different route just to show that there are so many ways of solving your problem as long as the math is correct, because we go through step by step and see if you didn't do magic. So now, in this case, do you agree that the f of x is equals to 2x 1 minus x squared to the power of half?
Affirmative. Yes, ma'am.
Yes.
So what's the derivative of this? So it's f prime of x is equals to 2 1 minus x squared to the power of 1 over 2. We differentiate this function first, then we differentiate that. That's the product rule, right?
Yes, ma'am.
Now, then this becomes plus 2x then we differentiate this. And when we differentiate this particular function over here, we can see we have to apply the chain rule. So meaning that we take the half here, 1 over 2. So this becomes 1 minus x squared to the power of 1 over 2 minus 1 times the derivative of an inner function, in this case is minus 2x.
2,
Are we all
ma'am,
together,
not
Lady?
x. Yes, ma'am, we are together. Yes.
Thank you. So this is equals to 2, 1 minus x squared to the power of 1 over 2. Plus, so this 2 can, what's this, times that half, it becomes 1. And then that x times that x becomes what? Negative 2x squared. So this is minus 2x squared, open bracket, 1 minus x squared to the power of negative 1 over 2. From here, guys, from here, what can I do? Should I leave it like this?
No.
So I can do what?
So you're going to say 2 the square root of the inside, 1 minus x squared.
So I can say what?
2 the square root of 1 minus x squared minus.
Okay.
Ma'am,
So
I was thinking if we can change the right hand side, like the 2x squared, then we put the 1 minus x squared, that one with the negative 1 over 2 below, so that we can get maybe the common factor of everything. I don't know if I'm correct.
You are right.
You are, but I want us to find the shortest method in this case. What do you think the shortest can be? And when you go as well, try to do, when you go back to do these exercises, try to do it your way first. Don't look at exactly how I did. Try to do it your way first and see if you can get an answer. So in this case, in class, we'll try to find shortest and simplest method. What can we do?
Can we say 1 minus 2x, both 1 minus 2x is over half, the other one is minus half. Can that be a common factor? Can we treat that as a common factor?
What, 1 minus?
1 minus x squared.
So you want me to treat that as a common factor?
Both. No, I'm asking, can that be, can we treat both as common factors, even though the other one is a minus half?
So the other one is a negative, so she has to take it to the denominator first, so that half becomes a positive, and maybe they can cancel out.
Yeah, I think so.
We
sorry,
can
ma'am.
Yes.
Don't you need to change the terms that are exponent half to square root and then make it a common denominator?
Okay, yes, we can do that. So let's see.
It's 2 roots 1 minus x minus 2x squared over
1 minus x squared 1 over 2 minus 2x squared over. So this is what you're saying.
Yes, but also the other one into square root, the first one.
And then you want to make it a common denominator.
Yes.
Getting it.
We can do that.
Isn't it?
We can also factor out 1 minus x squared over.
Isn't it? Okay.
Yeah, we can do that, and we can also factor out. Guys?
Ma'am, how are we going to factor it out? How are we going to factor it out?
I was thinking maybe
before that, do we agree that we can, because these are fractions, this is the same as 1 over that. Do you agree that we can change, make the fractions the same and then add and subtract whatever? Do you agree on that one?
Yes, we agree. Yeah, totally.
And then we can also factor out 1 minus x squared to the power, what's this? 1 minus x squared to the power of half. That's another way of doing it.
How?
Hey, you
How?
take out 1 minus, you take out 1 minus x squared, you put it on the side. On this side, you are left with 2. 2 minus x squared over 1. That's how.
But the exponents are different. There's a negative and a positive.
Well, actually, we took this down. The other one is down. Now they are both positive. You can see 1 minus 2x over half below 2x squared. It's positive. There's no negative. Over 1.
It can be over 1.
But for
It
one
can be
is
over 1.
wait.
But remember, if we are going to
Over 1.
Mm.
That's
hello?
impossible.
Yes, I'm listening. If you are going to,
If we are going to go ahead with what I'm seeing, we're going ahead with. Aren't we supposed to make the denominators the same, in which it will require that for the first term we multiply the top and bottom with 1 minus x squared to the power half.
well done. That's the first one. And the second one was factoring out. So people were asking, how do we factor out? That's the second one. We can go that route or we can go out the factor out. Can we look at the factor out just quickly? Do we agree what she said, guys? Yeah?
Yes.
We agree what she said, right?
Wait, what did she say?
She said that we make this, the denominator look the same. So we take this, multiply by this over that. So that this denominator can change as 1 minus x squared to the power of half, which is correct.
That's exactly what I was saying, ma'am.
Yes, but you can also factor out in this case, right? Okay, so let's do what she's saying. Let's start with what she's saying first. Are we all together?
Yes.
Okay.
Yes, ma'am.
And then we'll do the factor out. Remind me if we have time, we'll do the factor out. So this we know it's over 1. So this is 2, 1 minus x squared to the power of 1 over 2 over 1 times 1 minus x squared to the power of half over 1 minus x squared minus 2x squared over 1 minus squared to the power of half. The denominator this side is 1, so it's the same as 1 over 1. So now this is equals to, what is this? This multiplied by that, what is it equals to?
It's 1 minus x. That one will cancel each other. The square root will cancel each other. Then you'll be left with 1 minus x squared.
They don't cancel each other. The terminology is incorrect.
If multiplying bases,
I'm sorry, ma'am. I'm sorry,
Yes.
Do you remember? Do you remember?
Can I hear the person who says, do you remember?
Do you remember when I said let's change the? Can you just scroll up a bit? Just scroll up a bit to the previous steps. Do you remember when I asked that we change the exponent half to square roots, and then you make the negative half to a denominator like a positive square root 1 minus x squared.
Yes.
Then we can make root 1 minus x squared the common denominator. Multiplying that will cancel the square roots and we'll have 2 minus 2x squared minus 2x over root 1 minus x squared.
Okay, so I understand what you mean, eh? But in this case, I don't want us, because in the study guide they use roots. In this case, we are using to the power of half, because I just want us to do it in a different way.
Okay, so that means your next step from here would just be to make 1 minus x squared exponent half. So you're going to be left with 2 minus 2x squared minus 2x over 1 minus x squared exponent half.
Well done. So do you see that, remember, according to the exponential laws, if you have a to the power of half times a to the power of half, if you multiply same bases, what do you do to the exponents?
You add
We
them.
add the exponents.
Thank you. So half plus half becomes what? 1. So this is to the power of 1. So meaning that here, if you look at this, we have same bases. This base and this base are the same. So what do? We just add these exponents. So it means that here we'll be left with what? We'll be left with 2x minus x squared to the power of 1. Make senses? Hello?
Yes.
Yes, ma'am, it makes sense. It
Yeah,
makes a perfect
it makes
sense.
sense.
That's what I was saying. It
Makes
will
sense.
cancel each other. But anyway, it is what it is, ma'am. Let's move on.
You
It's
don't say
correct.
it cancels, guys. You don't say it cancels. Because if you're supposed to explain it
Doesn't
to someone, you
cancel
say
though.
it cancels. So it's 2, 1
It
minus
doesn't
x
cancel.
squared over, now the denominator becomes 1 minus x squared to the power of half minus 2x squared over 1 minus x squared to the power of half. Now, since the denominators are the same, you take the denominator the way it is. So the denominator becomes what? 1 minus x squared to the power of half. Then this 2 times 1 becomes 2. 2 times negative x squared becomes negative 2x squared minus 2x squared. So this becomes what? This becomes 2 minus 4x squared over 1 minus x squared to the power of 1 over half. Are we together?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
So in this case, I'm showing the study guide, instead of using to the power of half, they use the root. But as I say, this in what's this? The class will try to do it in a different form so that we can see that we get to the same answer. So that was the derivative. Do you see that? That was only the derivative, guys.
Sorry, ma'am. So we leave it like that. Don't further simplify.
Can you further simplify it from here?
There's half below there.
What half?
Half. One minus x squared over half. You can do the square root thing.
We
Put the
can.
square root of what?
We
Sorry?
can. We can write
What
it
do you
like that,
mean
but we've
can't?
not
There's
done
half
yet.
there. Half
Remember?
represents the square root.
Ma'am,
Yes,
before we
but
move
we're
on,
not done yet.
ma'am, can you please demonstrate the factor out one? I wanted to see that one before we move on, if it's possible. The
Okay,
factoring
can you
out.
finish the example? Then I factor out. I show you.
No problem, ma'am.
Yes. And then from this point, because we are not done yet, we can't just write to the square root of what, isn't it? Do you see that we were only looking at the derivative, guys?
Yes, ma'am. Yes.
So meaning that now we need to go and do the square root of 1 minus f of x squared. So in this
Yes.
case, so this means that dy over dx is equals to 2 minus 4x squared over 1 minus x squared to the power of half over the square root of 1 minus, what is f of x? Let's go back and see. F of x is 2x. So 2x, open bracket, 1 minus x squared to the power of half, close bracket, squared. Are we together up to that point?
Yes, ma'am.
And please
Okay.
repeat that.
So now we're substituting into the derivative formula. We found the derivative, so we substituted. And then we say 1 minus the function f of x, which we substituted there.
Okay, ma'am.
That's why we say dy over dx. Remember, you don't leave it like this. You continue. So then from this point, it means we have to what? Simplify what is under the square root, isn't it?
Yes, ma'am.
Now, me, I like writing it like this. Dy over dx is equals to, so that I don't get confused, 2 minus 4x squared over 1 minus x squared to the power of half divided by whatever is under the square root, 1 minus. Do you agree that according to the exponential law, it says that if you have a times b times c, for example, and you square it, this is the same as a 1 times 2 times B, 1 times C, 1 times 2. Do you remember that? This is the same to the power of 1. Do you remember that?
Yes.
Yes.
So meaning that
Yeah.
this one, the answer here, we square these ones, isn't it? So this becomes what? This becomes 4x squared.
4x squared, yes.
And then we square this one. It becomes what? 1 minus x squared.
Yes, ma'am.
Are we together there?
Yes, ma'am.
Yes.
It's
Thank
2
you.
times 1 over 2, yes.
So this then becomes what? Let's see. So this becomes 2 minus 4x squared over 1 minus x squared to the power of 1 over 2 divided by the square root of 1 minus 4x squared minus 4x to the power of 4. Then we go ahead and this equals to 2 minus 4x squared over 1 minus x squared to the power of half divided by, this becomes 1 minus 4x squared plus 4x to the power of 4. Are we done?
No, ma'am, we are not done.
Right. What do we do?
I think we can
Remove the square root.
I think we can write 1 minus 4x squared plus 4x as a perfect square, ma'am.
Okay, the terminology is wrong, but then yeah, I see what you want to go. Where you want to go. Okay, you can factorize it. This is not a perfect square, but you can factorize it. You're right. So how do you factorize it then? Guys, should I remind you your grade 10, 11, and 12 work?
Yeah, I was gonna write it as 1 minus 2x squared altogether squared.
So he is saying that we are factorizing, let me choose a different color. We are factorizing 1 minus 4x squared plus 4x to the power of 4. He's going to write it as 1 minus 2x squared to the power of squared. Are we all comfortable on how he got it?
Can you elaborate, ma'am?
It's not me who gave the answer.
Yeah,
Can the person who gave the answer elaborate? How did you get the answer? We want to know.
Ma'am, if you expand it the same way, it's gonna give you the same. That's why I said 1 minus 4x squared plus 4x is the perfect square of 1 minus 2x squared, all squared, all squared. So if you expand this, it's gonna give you the same answer there at the top.
It's not a perfect square. A perfect square is something that is a squared minus b squared. That's a perfect square. We call it a perfect square. This is one, when you expand it, gives you this.
I expanded it and it does give 1 minus 4x squared plus 4x to the power of 4.
Yeah, so when you factorize it, how do you factorize it? Guys, can you factorize 1 minus 4x squared plus 4x to the power of 4? Do we remember how to do that?
Yes.
No. Yes. Should I move on?
Isn't it 2x squared minus 1 to the power squared, all of that together?
2x squared minus 1 to the power of squared altogether. It's the same thing.
Yes.
But how did you do it? Because look at it, it's 1 minus 4x squared plus 4x to the power of 4. So want to factorize it, right? Now he says the answer is 1 minus 2x squared to the power of 2. You see? So I think the answer is correct. I think the answer is correct. But now how do we get to the answer that I think is correct?
I think I can give it a try.
Please give it a try.
Let's check. Let's open the brackets first. Two pairs of open brackets. And then at first we need the two numbers of which when multiplied they can give us 1. We'll start by writing them there. It's 1 on the first part and the other one on the second part. It's 1 1. I will look at 4x to the power 4, and then I'll look at the number that when the product will give me that number. It will be and that number, if added or subtracted, it must give me the middle number.
Well done.
And that will be minus 2x squared, and then it will also only be minus 2x squared.
Well done. Did you understand how he did it?
Yes.
Yes, ma'am, we got it. We got it.
Is there someone who says, can you please explain it in your way?
We always love your way, ma'am. Can you explain your way?
But
Please.
we always love your way. Okay, so let's do my way then. So we have 1 minus I love maths, but I like simple stuff. So you look at this number and this number. The coefficient of the first one or the second one. Do you see where I look? I look here and here, right?
Yes, ma'am.
Right? Are we together? The first step, I times those numbers. What do I get? The answer is?
It's 4 if you times
4,
them.
right?
Yes, ma'am.
Thank you. After timesing those numbers, I go and check what numbers such that I times them, they give me what? 4. Positive 4. Ne?
Yes, ma'am.
But when I add them or subtract them, they give me the middle number. What are those numbers?
It's 2, yes, minus 2. Minus 2 because
minus 2 and 2.
Yes, minus 2 times minus 2.
Minus 2 times minus 2. Let's see. Minus 2 times minus 2, they give me 4, correct?
Yeah.
When I add them or subtract them, they give me what? They give me negative 4. Well done. Then I go and check. Remember, I take this minus 2 and I write 1 minus 2x minus 2x plus 4x squared to the power 4. Do you see that?
Yes, ma'am. Yes, ma'am. Yes, ma'am. We see it. Ma'am, is it 2x or 2x squared? I don't know. Is it me or is it 2x or 2x squared?
2x squared, sorry.
Yes.
Sorry.
Yes.
Yeah, you're right. 2x squared. So the middle term has 2x squared, has x squared. So it will be 2x squared, 2x squared. Are we together there?
Yes, ma'am.
Now we factor out. And remember, when you factor, you remember grouping in grade 9, grouping or factorization and grouping.
Factorizing by grouping. Yes, ma'am. We remember it.
You group the first term and you group the second terms. Do you see that?
Yes, ma'am.
Now, when you factorize the first group, whatever is inside the bracket should also be in the second group. Are we together?
Yes, ma'am.
So when you factorize 1 minus x minus 2x squared, what will be the factor of it?
Minus 2x squared.
1 minus 2x squared.
Yes, ma'am.
Factor that. What is the common factor on 1 minus 2x squared?
It's 1.
Well done. You put 1 outside. Then you open bracket. 1 times, then you what? Isn't that you factor out what? Then you remain with 1 minus 2x squared.
1 minus 2x squared. Yes, ma'am.
Now, the second part, so this is equals to, the second part, this one, you need to make sure you factor it such that inside the bracket, you also have 1 minus 2x squared. Are we together?
Yes.
So when you factor out, what are you going to factor out here?
Minus 2x squared, so that the inner one Yes.
So that the inner one is also what? 1 minus 2x
2x.
squared.
Oh, okay.
So now you take this bracket the way it is, you put it here. So this is 1 minus 2x squared. Whatever is remaining forms the new bracket. It's 1 minus 2x squared.
2x squared times 1 minus 2x
So
squared.
because these are the same, so meaning this becomes 1 minus 2x squared squared.
Wow.
Yeah, that's quick.
Go and try with 4x squared plus 4x plus something. Those the one with x, that method, you will see it works as well. Are we all together now?
Yes, ma'am. It's now clear, more clear.
Thank you. So let's go back. So this is what? 2 minus 4x squared over 1 minus x squared to the power of half divided by the square root of 1 minus 2x squared squared.
Yes.
Wow. It's amazing.
So then
Awesome.
this is equals to 2 minus 4x squared over 1 minus x squared to the power of half. Now we want to change. Do we agree that this is the same as divided by 1?
Yes, ma'am.
So then we say times, remember we are changing now. The 1 becomes on top and this one becomes at the bottom.
But ma'am,
1
before
minus 2x squared squared.
before we move on, is it necessary to keep the square root now that we have the
No, I'm
square
just
out?
doing it step by step.
Okay, ma'am.
You'll notice that the steps in class are a bit longer because I'm doing it step by step just to show you how what disappears and what happens. Do you see that?
Ma'am, I understand.
Now we know that the square root of a squared is the same as a. So meaning that here we only remain with what? 1 minus 2x squared. Do we agree there?
Yes, ma'am.
So this becomes 2 minus 4x squared over 1 minus x squared to the power of half times 1 minus 2x squared. Am I done?
We can still simplify further.
So, Thomas, can you mute, bro?
Where can we simplify further?
So at the
common
numerator,
factor,
we can take out the common factor, which is 2, which will give us 2 bracket 1 minus 2x squared, and then we just cancel at the top and at the bottom.
Well done. Well done. There we go. We don't cancel, they divide. This divide by that is 1. So this is equals to 2 over 1 minus x squared to the power of 1 over 2. But because now there's nothing else I can do, I can take this into a, sorry about that. Where's the, ooh, what have I done? Okay, what have I done? There we go. So then this is equals to 2 over the root of 1 minus x squared. Do you see that? Therefore, dy over dx is equals to 2 over the root of 1 minus x squared. Are we all together, yes or no?
Yes, ma'am.
Yes, we are.
We're together, ma'am.
Thank you. So let's look at the, you see here, the steps are just like few, and we got the same answer. So as you can see in here, they continued with the square roots. They changed the square root from this point over here, and they continue with the square root. If you are comfortable doing that, then do that. Are we all together?
Yes, ma'am.
Yes.
Thank you. So should we, let me see, what time is it? Let's look at example 4.
Can you do that factoring part that you promised, or is it too late now?
I also want to know.
If you promise that if I do the factoring part now, you'll stay until the class finishes.
Oh.
No, ma'am.
So it means I can do the factoring part after.
Okay.
Yes.
Oh, okay.
Yes.
It's fine then.
because I don't want us to stay, okay, copy. So what happened is the more you practice these questions, you'll notice that's, what's this? At some point, you will be able to do steps that are correct. Your mathematics, as long as it's correct, that's what matters. So here, hey, it's also arc sign. Hey, I even crammed it now. I'm correct, right?
Yes.
Thank you. Ma'am. So what do we do? Should we do it differently? Should we substitute everything inside? Or should we do it step by step again?
Hey,
guys.
Are we ready to take off the training wheels? Substitute everything.
Step by step, man. Step by step.
everything
Want to see
inside.
what you're doing.
You want to see, okay, let's do it step by step. And then you will do, what's this? You remove the training wheel when you are doing it. Once you get used to solving the problems. So what is our f of x in this case? Our f of x is what? 2x minus 3 over 3x plus 4. How can I find the derivative here?
Quotient rule.
Thank you. You can't separate what? You cannot separate the denominator in this case. You can use quotient rule. Right? So it becomes more easier. So what does the quotient rule say? Is that I take the top, the weight, the bottom, the weight is, the top I get 2 minus 3 and then times 3 over 3x plus 4 squared. Are we together?
Yes, ma'am.
Yes,
Thank
we
you.
are.
Now, one mistake that a lot of people do is they try to to expand the denominator. Don't always rush to expand the denominator. Leave it like that and see if there's at some point it won't cancel or not. Right? Are we all together when it comes to the quotient rule? Yes.
Yes, ma'am.
So let's stick to the numerator first. So we have 6x plus 8 minus 6x minus 9 over 3x plus 4 squared. So this is equals to 6x plus 8 minus 6x plus 9 over 3x plus 4 squared. This 6x and this, they cancel. That's the proper term because they remove each other, they cancel. And then 8 plus 9 is 17 over 3x plus 4 squared. Are we together there?
Yes, ma'am.
Yes.
So meaning we found this one. Let's go to the denominator then. So the denominator is what? So we can write it dy over dx is equals to f of prime of x over square root of 1 minus f of x squared. So this is equals to, the derivative is 17 over 3x plus 4 squared divided by the square root of 1 minus, what is it? 2x minus 3, 3x plus 4. So that's 2x minus 3 over 3x plus 4 squared. Do you agree that we can also write this as equals to 17 over 3x plus 4 squared divided by the square root 1? Let's simplify that. This becomes 2x minus 3 squared over 3x plus 4 squared. Do we agree there?
Yes, ma'am.
Yes, I agree.
So what do we do from here? I think by now we know what we do, guys. What do we do from here?
Underneath the square root, we can make the both the terms inside have the same denominator. So in other words, we can multiply 1 with 3x plus 4 squared divided by 3x plus 4 squared, so that it can have the same denominator as the next term, and then we just simplify it in that manner.
Well done. So this will be equals to 17 over 3x plus 4 squared divided by the square root of, remember this is 1 over 1, times 3x plus 4 squared over 3x plus 4 minus 2x minus 3 squared over 3x plus 4. Normally, I like to multiply denominator this side times 1 over 1. So this is equals to 17 over 3x plus 4 squared divided by the square root of 3x plus 4 squared over 3. Was this 3x plus, this is squared?
No, ma'am, the squared was by your denominator.
Thank you, yes. So this is x plus 4 squared minus, I'm just doing things step by step so that I don't get lost here. 3x plus 4 squared. So they have the same denominator, so meaning we can deal with the numerator in this case. So this is 17 over 3x plus 4 squared divided by the square root of, the denominator remains the same, which is 3x plus 4 squared. So let's, do you see that the opening of bracket, the expanding becomes an issue when you have something like this, guys? If you can do expanding very quickly, it's so fine. But look at this. So we said we square the first term, isn't it?
Yes.
Hello? So this becomes what? 9x squared.
It's going to
and then we say 2 times
9x
4
squared
times 3x is what?
24x
Plus 24x.
16.
Then we do what? Thank you, plus 16. Minus, open bracket.
4x
We get,
squared.
Thank you, 4x squared.
Minus 12x.
Minus 12x.
Plus 9.
Do you see how it becomes easier now? Thank you. So let's simplify that. So this is 17 over 3x plus 4 squared divided by, let's simplify this. We have 9x squared plus 24x plus 16 minus 4x squared plus 12x minus 9 over, so the square root is over everything. Are we winning?
Yes, ma'am.
Yes,
Thank
ma'am.
you. So this is equals to 17 over 3x plus 4 squared divided by. Now, this and this, they give us what? They give us 5x squared.
Yes.
This and this, they give us plus 36.
6x.
X.
Plus
This
7.
and this, they give us plus 7 over 3x plus 4 squared. Remember the set properties that says we can write this as square root of a over b can be written as square root of a over square root of b.
Yes.
So let's use those set properties. So it's properties. So 17 over 3x plus 4 squared divided by the square root of 5x squared plus 30 plus 7 over the square root of 3x plus 4 squared. So from here we can change, you see that we can change the division into multiplication and swap the denominator and the numerator.
Yes, ma'am. Then the denominator on the left side and numerator from the right side, they cross out since they have the same, yeah.
They divide, well done. And remember we said a squared is the same as, square root of a squared is the same as a. So meaning that here the square root disappears. Do you see that?
Yes.
Yes.
Thank you. So meaning that this is written as 1 over 17 over 3x plus 4 squared times, now this becomes 3x plus 4 over the square root of 5x squared plus 36x plus 7. Now, this divides by this. So it divides one of them. Do you see that? So then this becomes what?
No,
this becomes 17 over.
Wait, ma'am. No,
Yes,
no,
yes.
you don't remove the whole. You only remove the exponent since it's two of them.
Wait.
What happened? Oh yeah,
Yeah,
you crossed out all of them on the left side denominator, but you only remove the squared since there's two of them as the exponent.
Yes, so you're left with one.
Yeah.
7. And that's what we got. Should we check if we are correct?
Yeah. Let's check.
There we go.
We are correct.
It makes sense.
see
I don't
that?
like the fact that they always use
And
ox sign.
So now, so it means I shouldn't use oxide. Eh?
No, man. You're
So it
making a
means-
bad habit of cramming now.
So it means that what happened is you can, as soon as you get used to it, you'll see as we have a lot of steps. Because why? Because of we did step by step. But as soon as we actually included even unnecessary steps. But as soon as you able to practice these problems and get used to them, you'll be able to do, like you see, like 5 steps, like in the study guide. Are we all together?
Hey man, why is it number 2 of
Ma'am, before you
activity 2 is something else?
Ma'am.
Yes.
Why is it something else?
I just wanted to say that we were still able to simplify the last example that we just did now. We were still able to simplify further in the square root.
What are we simplifying further? Yeah.
That 5x squared plus 36x plus 7, it can be simplified into bracket 5x plus 1 close bracket open bracket x plus 7, but I guess not really needed. Seems like in the study guide it's complete as this.
Okay, let me help you there, right? If it happens that you end up factorizing like this inside the bracket, then don't do it.
Okay.
Especially in the final answer, right?
Yes.
But you can factorize that if you need it maybe for another step.
Okay.
Yeah.
Wait, why is that, ma'am? Is it more messier or it's not clean if you leave it as a factorized form?
Let's leave it in factorized form and see how do you look at it. So she says it's what? In a factorized form?
It's 5x plus 1.
And
x plus 7.
So if you leave it, how does it look to you?
Yeah, it looks weird.
Yeah.
It looks like we have to continue when it's like this.
Yes, it means that you have to continue at some point. And remember that when you have things like that, when they say simplify further, they want it to look simple like this.
Yes.
Yes. Guys, can you use that method that I showed you to actually factorize and see if you get this? 5x squared plus 36x plus 7. Do you remember it, isn't it?
It's worth a shot.
Did I explain it for the last time or you're okay?
Explain it for the last time, ma'am.
Yeah.
And this one is kind of different because they have to multiply the 5 with the 7, then they find the factors which you add, and they give you 36.
So 5 times 7. Well done.
Yes, ma'am.
Which is what? 35,
It's
isn't
35.
it? So you want numbers such that when you multiply them, they give you 35. When you add them, they give you what? 36. What are those
36.
numbers? Hello?
Yeah, we're thinking, man. Numbers where you multiply gives you 35. But when you add them, gives you
Ma'am, it's
36.
35 and 1.
Hey, that's what I'm thinking.
Oh,
How fast?
hey, okay.
How?
Okay.
35 times.
Oh,
35 times 1. 35 times 1, they give you what?
36.
yeah.
Thank you.
Okay.
I mean, 35 times 1, they give you 35. 35 plus 1, they give you 36. Do you see that? So
Yes,
then
ma'am.
it means that now you need to be very careful, especially when you are substituting. You need to be very careful if you can be able to factor out. For example, if I write 5x squared plus 35x plus x plus 7, right? Here, if I group this first term, let's group the first term, right? And the second term. What can I factor out here? Guys.
5x. 5x.
5, thank you. 5x, right? Open bracket. Then I'm left with 1 plus what?
Yeah, you are left
You're
with
left
x,
with
not
X.
1.
Left with
7.
X
X,
plus,
not 1.
Oh,
plus
sorry,
7?
I'm left with x
Yeah, plus
Yes.
7.
plus 7. Plus, it means in the second part, I have to factor out what?
Yo.
1.
1.
Yeah, 1.
So meaning that the brackets are the same, we drop it the way it is. Guys, I'm not teaching you something new. This is grade 9 work.
Revision.
Sorry. There we go.
Is it fine if I can, maybe propose an easier method?
Let's hear.
Okay, so let me just quickly send a picture of my work in the group chat. I mean, in the MS chat, and then
Okay.
it'll be easier to explain from there.
Okay. I'm waiting for it.
Okay, it's sending. Yes, it's sent in the group. So basically, the way that I was taught how to do in high school was that if you look at 5x squared plus 36x plus 7, you always look at the middle term, which is 36x in this case. So you're going to put 36x inside a box, and underneath that box, you're going to have two columns, one on the left and one on the right. So the column on the left, you're going to write two things that you can multiply with to give you 5x squared. So in this case, it's 5x and x. And then on the right side, you write the two things you multiply to give you the last term, which is 7. So which is in this case 1 and 7. So then
Well done.
after you place them out, you're going to then do cross multiplication. So in other words, the 5x and the 7 they are across each other. So that means you're going to multiply them. If you multiply them, and you're going to get obviously 35x, right? And then you do your other cross multiplication, which is the x and the 1, which is 1x. And then after doing the cross multiplication, you add together, and then you make sure that it is the same as in the box, which is 36x. So if we say 5x times 7, you get 35x. You add it with x times 1, which is 1x. So it's going to be 35x plus 1x gives you 36x. So once that is confirmed, that means that those are the vectors you're going to use for your brackets. So then you write open bracket, you're going to put in the 5x, and then you're going to put in what is across it, which is the 1, which is plus 1. You close the bracket. Then you open a new bracket. You're going to write the x, and then you write what's close to it, which is the 7. You say plus 7. So that's the easier way to go about it.
Well done. Did you hear that, guys?
Yeah.
Yes,
We
we
heard
did.
it.
Yeah, I'm just putting a disclaimer. I'm taking it to my undergrads. I've copied it now as well. Okay, guys. So then you go through the post examples and make sure you go through them. And if you have a problem, you let me know. Are we sorted?
Question 2 of activity 2 looks something else, man. Yeah, okay.
And I've noticed I did 2 sections in one video. It's okay then. No, it's fine. No, it's fine. Yeah. So are we okay?
Yes, ma'am.
Yes.
So I think that's it for today.
Just
Yeah,
a
just
question. Okay. Oh, the
What?
factorizing, what one?
Question here.
Okay, good.
Yes,
Okay,
can I ask a question?
Okay.
Wait. The question is regarding this work.
No, you said, okay, right. No, it's not.
Okay. Then we have to ask only questions regarding this work in this video. Then as soon as we stop the recording, we can ask questions on another work. So can I stop the recording for this work?
Yes.
Yes, well, maybe you can do that
Yep.
factorizing example
Oh yeah, the factorized part, man. You can't leave.
Man,
on
before we
example
close,
3.
The factorized part.
Yes.
Where was it?
I think it was example 3 where you said that, but there's another way we could factor what we were doing there.
I think it's here, right?
Yes, ma'am. Yes.
Okay. So let me factorize it. Let's see. Okay, so with this part, what I said was then you can actually factorize the, okay, let's go to where we were from here. Isn't that, this is where we got it from here. And I said you can factorize it
ma'am.
from here, ne?
Yes, before the euro signs there.
Yes, so let's do that. I've opened a lot of, what am I doing now? Okay, give me a sec. Okay, so someone was asking, how do we factorize this, right? Now, let me just show you with a simple thing. For example, if you have a to the power of half, ne? And let's say you have b here plus, no, let me not say b, 2 here. And then you have minus 2x a to the power of negative half, right? And you want to factorize this. Do you see that a to the power of half are a bit similar though?
Yes.
There's a to the power of half and a to the power of negative half. So what you can do is, do we agree that we can take out the 2 as well because they are common?
Yes.
And then
Yes,
we can
yes,
take
ma'am.
out the 2, and then we also take out the a to the power of half. And then what do we remain with? We remain with 1. Because we know that when we multiply this back again, it'll give me what? It'll give me this. Are we together?
Yes.
Yes, ma'am.
Now, minus x. Now, I want a to the power of something such that when I multiply with this a, it gives me what? It gives me negative half. So it will be a to the power of what?
-1.
Well done. So it will be a to the power of -1. Like this. So do you see how I factored it out?
Yeah.
So meaning that this will be equals to 1 minus x squared to the power of half 1 minus x squared to the power of -1. Are we all together there?
Yes, ma'am.
So then
Yes.
this becomes 1 minus x squared to the power of 1/2. Then this becomes 1 minus x over 1 minus x squared. So then from there you can do, make them the common, the common denominators, and then simplify this basically. That's how you factorize the part of factorizing. Then you simplify this.
Thank you very much, ma'am. It's a lot easier now, and yeah, totally see it. Thank you very much.
You're welcome. Are we all okay there, guys?
Yes, ma'am.
So, ma'am, previously you started by taking the one with the negative sign, the negative half down. But then when we tried to factor out, I don't think we were able to. Can you try to do it like that? Let's see if
You
you
can still factor out.
Okay.
You can still factor out even if you put it like that. It's just you need to remember your exponential laws.
Yeah, because when we factored it out, and I thought below we are going to be left with 1. You said no, there's no 1 there. Then for me it was a bit confusing because I could not see how you can multiply it back to the equation that you just factored out. Because when you
I
factor
see.
out, you have to see that when you multiply, you have to get back the equation. So I didn't
But in
see
this
how
case, you can see that when you multiply here, you get back to there, right?
Okay.
Can you see that?
I can see, especially because of this -1.
Oh, so this is x squared, sorry. Yeah, this is x squared. Can you see that?
Yeah, I can see. I'm just referring to the -1. I think that's the little missing piece from the previous one. I
because
don't know how.
it's because even if you put it
Okay.
as the whole thing over x to the power of half, when you factor out, it should be to the power of what? To the power of 1.
Okay.
Yes.
Okay.
Which is this thing as well. So this is what you're going to get basically.
Okay, ma'am.
Yeah. So can I stop the recording?
Yes, ma'am. Thank you very much. Thank
Yes,
you.
You're welcome.
Hope you have a lovely day, have a lovely week. Thank
So,
you.
ma'am,
Bye.
next week we're
Are we
doing
done yet?
week 6. Hey, ma'am. Yeah,
Where did she go?
She disappeared.
Yeah.
I think she left, guys. I'm sorry.
No, but the recording's still on.
I think.
Are we done yet?
Nah,
Yeah,
nah,
we're
nah,
done.
nah, nah,
We're
nah. We
done
still
for
have
today,
another
okay.
unit to do.
Can anyone